So, welcome everyone. So we are the fourth keynote of this, the ECCB. Sorry, the fifth. So the time is passing by very fast. So today we have with us Graciela Gonzalez-Hernandez. She's the Vice Chair for Research and Education in the new Department of Computational Biomedicine at Cedar Sinai Medical Center. So she moved to the Cedar Sinai in late May, so 6 months ago. She is moving from the University of Pennsylvania, where she has been working in the Department of Biostatistics, Epidemiology, and Informatics. She's specialized in natural language processing in different fields. She's going to talk about this topic and a trajectory of 18 years, if I recorded well. 2022, the professional trajectory, 18 in the natural language processing associated to biomedicine, and different activities around shared tasks, for instance, biocreative and others. And I don't want to take more time for have a really nice keynote. So, Graciela.
Hola, buenas tardes. I've been wanting to do that forever, to greet an audience in Spanish. So I am very, very pleased to be here. It is my honor to share with you a little bit of what I've been doing in the last few years. My talk today is going to focus on text mining for digital epidemiology. It has been a quest of quite a few years, arriving at how natural language processing could actually be used to enact change, to make actionable knowledge available to scientists, all the way from trying to get genes and gene function extracted from text, which is exactly how I ended up meeting Alfonso quite a few years ago in BioCreative 2, and then moving along and finding this path towards text mining for digital epidemiology. So thank you so much for being here. I hope that we can share a little bit of these insights, and I will welcome any comments and tweets. I have my Twitter handle right there. Feel free to interact that way. I find that it is the easiest way to later answer questions. Obviously, there's like an opportunity for questions here as well. So thank you so much. And with that, I wanted to share just a little bit if this lets me, of what I'm doing at Cedar Sinai Medical Center. Recently moved, as I mentioned, from 5 months ago from the University of Pennsylvania. My academic career spans this 22 years, and I am very excited to join Cedar Sinai for a very focused attempt at realizing a lot of these ideas that through funding from the NIH, National Institutes of Health in the United States, I had been trying to advance. I think they have a great effort, and for the last 2 years have been pushing for data science be more meaningful for advancing clinical developments. So my particular area in health language processing seeks to bring all of these different sources of real-world data, including electronic health records data, into an area that it can be used by scientists. So pharmacovigilance, digital epidemiology, I put it as a sub-area, for clinical decision support, geographic location enrichment, and lately for SARS-CoV-2 sequence enrichment. So I'm going to let you a glimpse at some of these projects as we move along today. But first of all, what do I mean by digital epidemiology? It is simply the attempt as using data that was generated outside of the public health system. That is data that was not generated with the primary purpose of doing epidemiology in the first place. So using all of that data that's out there and trying to bring it in to enhance what typical epidemiology can do, which is study these trends, these distributions and determinants of health-related states and events for specified populations. So there's many different aspects to that little definition borrowed from the CDC. that allow us to see the challenges. Throughout the presentation, I want you to think or get the perspective, have the perspective of what will it take to use data that's out there in social media, in electronic health records, and other aspects, and then bring it in when it was not meant to be used for this. So there's a lot of challenges along the way. Obviously, it requires access to a large volume of data, and also to advanced analytics of this type that will allow us to then tap into this real-world data. One side discussion, I am not going to dwell on it. This is this ethical challenge. There's always this question in the back of people's mind when I start talking about what we do with social media, what we do with other types of data, even electronic health records, is privacy and whether we're invading somebody's private life and private information. So I have talked about it. There's a whole other talk about the ethics of using social media data, the ethics of using electronic health record data. Suffice it to know for now that, yes, this was all done, all the research that you're going to see was done with the Institutional Review Board oversight at the different institutions that I've been at, and it continues to be, and I'm always very mindful of that. Sometimes going above and beyond, trying to get this notion of what I call common sense. When something is too private to share, you won't see very private, very telling tweets on screen today. What I share, I usually share with that in mind. So as I said, it's a whole other discussion. So for now, let's understand what I mean by real-world data. So as I mentioned, it's electronic health records data. That's both coded data fields, that is the things that are with ICD-9, ICD-10 codes, free text and structured nodes, unstructured nodes, and then some associated imaging, genomic and other lab data. So all that the electronic health record contains will be considered real-world data. Social media, Twitter, Facebook, Reddit, and health forums bring the patient voice to the forefront and allow us to hear directly from them what they think about their disease, what they think about the medications they're taking, beliefs that they have about either their disease or the progression of their disease. Sometimes misinformed, but sometimes quite accurate. And this voice that needs to be heard, needs to be brought into other forms of health data. Sensors and wearable monitors, but also I'm adding published data. The reason I call it real-world data is because it's meant for humans and is distributed in a media that is not really very friendly to lend itself to extraction. So published data has a whole other category in my efforts to bring all of this real-world data to actionable level. So the U.S. Food and Drug Administration didn't want to make it a big effort that this is the only entity in the world looking at this. Obviously, it is not. But they have made an effort to do definitions of real-world data and real-world evidence. So we're walking from what will it take to get real-world data turned into real-world evidence, where we can use it alongside other sources of data, where we can distill it and systematically acquire it so that it can be used in epidemiological studies. So what is this path? Well, it takes, as I mentioned, extracting data. Retrieval efforts are often biased. So I'm going to mention a few challenges here and there and try to address some of them. It will exceed, obviously, the time of this keynote if I were to do all of this in detail. But just think through this and try to picture what it will take. So the retrieval efforts are often biased. So with this world of data out there, we as scientists have a responsibility to design our studies in a way that will allow us to balance this data. And I'll show you an example of that later. So extracting data also means machine learning, natural language processing, and other methods for classification, extraction, and even normalization of concepts in order to be able to use them. However, they are mostly developed for one specific purpose, designed around a specific data source, and often not shared. So that's a big, big problem. The other problem is the progress of the state of the art. As NLP developers, we've seen in the last 2 or 3 years a tremendous amount of progress in the methods that we can use. If we cannot, if we don't keep up, then we will surely have an outdated method applied to a problem. And that presents down the path to this real-world evidence a lot of difficulties in realizing the potential of real-world data. So then, after we have extracted, we have to account for validation. So what does it mean? How can we prove, or how can we make sure that the data that my method extracted means something or is accurate enough? So validating the methods is a key step in making sure that our data will be able to be used down the line, be able to reach that status of real-world evidence rather than staying at real-world data. There is actually no certification at this point on the quality of machine learning and NLP methods. Even published papers sometimes are done wrong. There's errors in them that are not pinpointed in the publication process. So there's some validation, some published papers that announce a specific performance for systems that are not actually done properly. So standards, so I've heard a lot about standards and benchmarking in the conference this year. And so that's exactly what will take us from real-world data to real-world evidence. Gold standard annotation at this point is scarce, it's an expensive process, it's often overlooked or is desirable skipped. So you get a very small data set to validate your method and you're happy with it, and it's the same author that annotated the data set. So the proper protocol for annotation and gold standard development is not followed. That's a tremendous challenge for validating and trusting the system that emerges from this. So validating certainly requires investment of effort, time, money, and it is, though, the key at making our case for this data to be useful. So proving the value and proving that large-scale use of this data is a step that will move science and will move epidemiology to the next step is a key development. It's a key part of it. So validating takes us to proving, to obtaining funding for it. It's often doubted when you put a proposal out that includes real-world data. The criticism that comes back often includes many of these aspects that I'm mentioning. It's not valid. It's full of noise. You won't be able to use it. You won't be able to get it. So all of these complaints, if we follow a systematic approach, if we have the publications, if we have the methods and the means to validate them, we could move along this path. And finally, using the data. Even when all the methods are perfect, sometimes domain experts, clinicians, and so on do not trust the data fully. They don't know what to do with it. What are we going to do with data extracted from 14,000 patients or 30,000 patients or 100,000 patients? So the methods for analysis have to be developed and incorporated into the studies so that free text concepts can be then included in these studies. Technical difficulties as well, where the volume of data often exceeds the current infrastructure. Just as a token example, we were trying to get data from clinical records. We provided the concepts that we wanted, all the ICD-9 codes that we wanted, and basically it came back like 2 or 3 months later saying that it was too much data, that we needed to reduce it. And that process was repeated. We needed to reduce the number of codes that we wanted to include. And there was no argument about, like, well, those are the ones that we need. Well, they came back with, like, it's too much data. It's like, what's the problem? We need that for the study. So it goes back and forth like that. So the current infrastructure is not ready sometimes for this volume of data in order to have a systematic studies. So let's look briefly at electronic health records data. It is underutilized, and you're going to start noticing a pattern here in my talk. about what is the number one difficulty or the number one challenge, I guess, that we have in front of us. So it is calculated that 70 to 80% of EHR data is ignored in large-scale studies. This is a question that came up when I was working on preparing a paper. I'm going to show it to you next. I just wonder, like, how much of the data that's in the electronic health record is not used, is in an unstructured format. Is 70 to 80% of it is actionable information that's not used. And only about 0.5% of the studies based on EHR data currently use free text. Mind you, this is based on one specific study. I couldn't find the answer to this. It's like what percentage of studies right now are using the unstructured portion of the electronic health record. So this number that I'm giving you is the result of one particular study that we conducted. It is now published in the Annual Review of Biomedical Data Science. We were looking at big data analytics to address sex-specific biases in an understanding of disease. So basically what we looked for is publications that claim that there was some difference based on biological sex that was found using electronic health record data. It's a very broad question, basically. So we use keywords to calculate, to try to see how much of it was. So first we got on Medline, and we use other sources as well, basically. When you go to the paper, you can see the other ones. I'm using the numbers from Medline only. So we found 67,424 articles in Medline that included sex-related terms, woman, man, so on, and also terms that indicated that they found these disparities or difference in outcomes. We didn't put it in a specific disease. We opened it up to any kind of disease. So 67 and so articles. After that, we added terms for natural language processing, machine learning, artificial intelligence as a proxy to try to find out when they use unstructured data. Because short of doing very small studies where everything was coded by hand, you need these methods in order to use in large-scale studies in order to derive any data from the unstructured portions of the electronic health record. And we found only 469 out of this 67,000. So it's shortly like 0.6%. I just didn't want to put too much weight on our specific search items. So less than 1% is as close as I can let myself get at a number. It's still very striking. Less than 1% of the articles actually use the unstructured portion of the electronic health record. So we can look at it like that little sliver at the top. Or in what I chose to be, I needed an image to communicate how urgent it is to work on this problem. And I think the best that will appeal to everybody is what happens when your phone gets to 1%. That same urgency, looking to the charger and plugging it in before it dies, that's exactly where we are in this. It's like we need to recharge this research. We need to rescue all that data at the point where we can, which is when we're extracting it, we're obtaining it, and not do studies that are in essence incomplete. So this is one paper that I like the way it was designed. It's not my paper. This was designed around the question of what will we gain if we use unstructured data. So it answers the question about actionable data in electronic health records. See how much of it is out there. If we just do code like we've been doing in this 99.5% of studies, what are we getting? So this part of the chart shows you what they found is occurrence of hypoglycemia and its severity from electronic health records of patients with type 2 diabetes, okay? So they found any mention of hypoglycemia, a serious event, mild or moderate, or unspecified. That's the yellow, the blue, and so on. So this is just with code. And then they continued the study. They did it another way. They used NLP. So they wanted to find mentions, again, of any occurrence of hypoglycemic event, serious event, mild or moderate, unspecified, and so on. So you see all the numbers growing already. This is from the same set of records using only code to using NLP. When you combine the two, those are the numbers that you get. So this is pretty striking. It tells you how much data we could be missing in a study. And not only that, it's like the conclusions that you draw could be flawed in that sense if you don't use all the methods that you have to get all the data available. Because, for example, having the total number of patients that you are studying with type 2 diabetes, and you want to see the percentage of them that are suffering this kind of event, and you conclude that it's about 8% if you stay on that side, right? And therefore, the actions that will be taken clinically to address something that occurs in 8% of the patients will be designed around 8% of the patients. But the real number is close to 30%. Totally different set of actions. If you have 30% of the patients having this kind of event, the actions and the steps that need to be taken are totally different. So the studies themselves, if we limit ourselves to just one way of getting the data, are in essence biased already, just by the type of data, type of method that you use. Another bias is just the sample distribution. This is much, well, relatively simpler to address, but this is just in some of the studies that we found, is the breakdown for male to female patients. And remember, these are studies that were specific in saying that their finding was related to biological sex. And we found rates from 75 to 25% male to female on the far left to the other way around almost on the far right. So ideally, you want to be somewhere in the middle where it's balanced, okay, or there is a reason for the unbalance. So addressing and looking closely at the data that you're using will be one of the other biases to address, not necessarily one related to electronic health, to text mining of electronic health records, but sometimes it is though, because you have not for biological sex in general, but for example, for race and age, sometimes you have the data in the unstructured portion and not in the coded portion. On another study, so now switching to social media data is underutilized. Over the years, I've been funded by the NIH for 9 years now, working on the question of how can we use social media data for pharmacovigilance. We have published numerous papers and demonstrated the value of social media, and yet it's very, very slow to be picked up by regulatory agencies, even by physicians for educating. So little by little, we've made progress from like 10 years ago when this started to now. The methods that we've developed, we shared repeatedly, organized the social media mining for health workshop and shared task over 7 years now, each year running about 6 or 7 shared tasks. I'm a fan of challenges, and I have Alfonso to blame, I suppose, because that's the catalyst of a lot of this idea. So since I started, I've been sharing data, been trying to let others kind of jump into the action and improve the method. So we've seen a lot of progress over this time, from that very first paper that started all on trying to find mentions of medications and adverse reactions 12 years ago, something like that. We happened to have that first paper that was published on it. We have seen that social media data can be used effectively. And right now, what we know, it is used to inform other studies, such as systematic reviews. It is used also, believe it or not, by the FDA. So the FDA, in what I call the very first official recognition of use of social media data, and this webpage, the link is there, they have this paragraph there. The agency will continue to monitor social media and online marketplace promoting and selling fraudulent COVID-19 products. They don't say how. I mean, I have an idea of how they can monitor it, but there's no paper published by the FDA saying how they're using social media data to monitor these products. I would really like to know. But this is the first in the United States of recognition. Europe and the UK are a little bit ahead in use of social media. One of my colleagues, Sue Golder from the University of York, have been working on this since 2015 with funding from NHS. They were monitoring what mentions of adverse reactions in social media were there for the drugs that they were considering for inclusion in the, as NHS allowed medications to be prescribed. So there's a little bit more done in Europe. In the US, there's little or none. So all these data, we have to think of social media as people out there, expressing their ideas freely, expressing their opinions and their beliefs and their experiences with medications and other health conditions, sometimes very clearly. So that chain of tweets in the middle that you see has very specific details, both about the user and the diagnosis. So I've been diagnosed with obsessive compulsive disorder and dysthymia. And some medications, I've been on antidepressants since 2016, so on. And then this tweet, as is often the case, triggers others. So sometimes we have one tweet and there's another with similar experience, and so you see the retweet with comment on top. Also has many details. Obsessive compulsive disorder and anxiety, been on therapy since 2 months. The direct user experience is very striking there. And yet you'll see that, and some people say, well, this one tweet, how will you get enough? So here I can already picture a pipeline where we could collect about obsessive compulsive disorder. It's not a research that I'm doing right now, but it could be done. And then try to see what is it that impacts their life. So impact in life, beliefs about it, types of treatment, and so on. All that can be obtained. Obviously, and I love Twitter for this, you also have to deal with noise. So that tweet next to that at the bottom, I think that's diagnosed with a chronic fear of giants, will have to somehow be disentangled from some of the others. This is what I did is a search on I've been diagnosed with. And it's the search that I have most fun with in general. And I always wanted to write a paper about that, so I've been diagnosed with on Twitter and what it gets you. So it is a lot of content. And the challenges for natural language processing is obviously distinguishing the valuable content from the noise. And that's what we've been trying to do over the last year. The NLM in the funding that I mentioned focuses on social media mining for pharmacovigilance. We published the first complete pipeline that takes you from tweets collected on medication names and their variants. We have a few papers on that end of the pipeline and papers along the way as well. This is just one that is the first one that has the complete pipeline published. So we include classification of these mentions, name entity recognition of the same, and normalization of the mention to specific MEDRA terms. And it is all validated. It is a usable pipeline. It enabled for the first time or ongoing research in this realm is a paper on understanding signals from social media. We have the largest collection of medications mentions since 2017. I've been collecting tweets. I think it's like 1.5 billion tweets at this point in time. And now we're ready to process them. So we are actually in the process of analyzing and publishing what I feel is what I owe the NLM for all this funding over these years, which is the answer to the question is, what can you do with social media data regarding mentions of adverse drug reactions? What is it good for? How can we use it? So that is work in progress, but this is the latest that we have in methods for addressing it. What we've been doing throughout this is this qualitative studies on what comes in social media. So this one is published in JAMA Network Open, assessment of beliefs and attitudes about statins posted on Twitter. And it is a purely mixed method study, just analyzing by hand this. But in order to make this possible, this study possible, we have to boil down all those billions of tweets into something that we can the domain experts to analyze. So getting to that point takes also annotators at the beginning of the pipeline that can enable me to develop the NLP methods, and then the NLP methods work for the same humans to give them something that can be analyzed and published. So, unique findings from social media. This is the first paper we had where there was something new found in social media, not published in elsewhere with other data, with other methods. So in this one, we found that people express their concerns or personal beliefs and attitudes about statins. One in particular call or attention is called the risk compensation behaviors that were expressed. Basically, statins, if you don't know, are taken for lowering cholesterol. And they are, in the UK, they are prescribed to the whole population, basically over 55, I believe it is. And some people take them, some people don't take them. Anyway, those that do, in this particular study, we found that they refer to this behavior, so they perceive themselves to be protected from the effects of cholesterol and bad cholesterol by taking statins without having to do anything about their diet and without having to do anything about their physical activity. Out of those that we found, there were some that specifically expressed the behaviors that we were referring to. So basically, they said things like, baconator night, so we have triple beef and bacon and so on, because I have to, then I'll double my Lipitor, or I double my medication for statins. My statin medication. So we have all these examples of people actually saying these things. It's like they are literally protected by them. Or, I'm eating healthy. I don't need it tonight, so I'll skip them for a week. And so these alterations of treatment in relationship to life, or their life choices, is not what doctors will expect. Because what happens is 6 months later, they go to their doctor, and the doctor asks, like, well, have you been taking your medication? And they say yes. They have no idea of these little adjustments of life that they do behind the scenes. And they are very, very important. So we are advancing our studies on these kinds of findings where we have hints about adherence and medication change and what people do with their treatments in real life. The path we took for moving into this adherence and medication treatment tolerability, instead of trying to find non-adherence directly, we broke it into two. Non-adherence is defined as not following the treatment given by a physician without the physician's knowledge. So this last part is very hard to prove. So you cannot prove from a tweet that the physician doesn't know about this medication change. So what we did is those of you into the methods, this is a methods paper on how we use active neural networks to detect mentions of changes to medication treatment in social media. This is, again, the first paper that does it in those two steps. Most papers you will see say non-adherence, but it's technically incorrect to try to jump to that one because you cannot really tell in most cases. What we found is the majority, 19.2 of the instances where people express the reason for changing or switching their medications have to do with adverse drug reactions. And this is, there's another paper, I didn't put it in the presentation, where we looked at what were the published reasons in a study for non-adherence to statins, what were the published reasons, and this differs from that. So our number one finding here is that people don't adhere to statins because of experience of adverse drug reactions. So we're yet to verify this. This is just to illustrate how there are valuable pieces of information that can come from social media if done properly. A bulk of the work that we've done with NLM funding has to do with studies in pregnancy. Adherence and non-adherence was one of the foci that we follow in this particular grant, and the other one was pregnancy. So we collected a cohort that now includes very precise 150,000 pregnant women collected over 5 years. It's not pregnant over 5 years. is collected over 5 years. So we do have multiple pregnancies, though. So it didn't come up right there. So anyway, so we have 150,000. For these women, we used to publish, for those of you that have seen it, over 500,000. What happened was, when we went to do studies, we still had to find out the pregnancy time frame. So this illustrates the problem. So we got a tweet where they say they're pregnant. We figure out the baby's due date. So if you see, probably for this timeline, the July 11th tweet in 2016, right there around the middle, it's time to announce that I'm having a baby. That's what was identified first. Then we got the timeline. And then we need to figure out when the baby was supposed to be here. So today is my due date is a very good hint. That's November 7th. And from that, we count back and we go to the beginning of pregnancy. And that's what we call the pregnancy time frame. Well, for our initial collection, we were not restricting ourselves to timelines of women that we can tell their pregnancy time frame. And then we added that so that we could facilitate studies. We need to have the tweets over pregnancy in order to do studies in pregnancy. So therefore, we decided to go for the more precise cohort, even if it meant sacrificing over 350,000 users. It pained me to do it, but it did facilitate a lot of the studies that we did afterward with it. So we have a study, COVID vaccine in pregnancy. This was the first paper in that sequence. We're still doing more studies. So this was basically to prove that we could do this. We could get dimensions of getting a vaccine during pregnancy and other studies to follow. There's more. I mean, we have another one on different aspects of pregnancy, pregnancy outcomes. We have that in NLP and so on. So others will follow. Finally, so we can hopefully approach some questions. Published data is underutilized. This one brings us to the COVID era. Okay, so this research is funded by the National Institutes of Allergies and Infectious Diseases. We've had funding for it for another cycle, focusing on geographic locations, but this one, we have been concerned about the amount of data in GenBank, and many of you here probably use data from GenBank, that is published and is made available, great, but the deposit of these data sets in GenBank follows usually a scientist's desire to publish a paper. And what is in the pipeline of science at this point is paper first. So publication first, driving scientific discovery, hinders large-scale studies. So each of you as an investigator has your study, you have your sequences that you're depositing there, you publish your paper. Many times, two things happen. The data is published first, and there's no manuscript to go with it. The manuscript comes later, or there's an archived version of the manuscript, and that's what's put into GenBank. And you change slightly the title of your paper when it was published, so none of the automatic traps of GenBank or what GSAID used to do that, they don't do that anymore even, and then it won't be linked. So what we found for SARS-CoV-2, all of this you can imagine, world pandemic, everybody's putting the sequences out. So we found 748,000 in GSAID and 117,000, in GenBanks, 117,000 in GenBank. And we tried to see if the papers were linked. And lo and behold, we have 3.4% only of those in GSAID have a paper, and GSAID discontinued putting that. I guess they realized that scientists were not putting their paper links in their sequences back to the paper, and they discontinued that. So right now it's not even available. You cannot get the paper that corresponds to the sequence data that's published in GSAID. GenBank continues to do it, but only 1% of all the sequences have it. It's a big problem, because what it means is everybody expects to get to the paper first, and then you do the sequence. But if you wanted to just study all the sequences out there with specific population characteristics about it, say by sex, by biological sex, by outcome, by any other geographic location, by any other demographic characteristics, you cannot really the way things are. So we were given funding by the NIH to remedy this, and we're working on it. So the idea is upper right with the letter A over there is a GenBank record. So we locate which, if there is a paper linked to it, we go get the paper. In this case, we found the paper, and that paper in turn cited another paper. So we did 2 jumps. And in that second citation, it's not the one related to the sequence, but it's like the same sequence was used for both studies. We do find age, we find the location, we find symptoms, we find outcomes, we find comorbidities, and we find a lot of other data that can enrich the GenBank sequence for that patient and then be used in larger studies. So we're working on this. We have been working on this for a year. Right now, we're focusing in relinking sequences with papers. Again, if you were able to do a search of all sequences for specific demographic characteristics or even COVID outcomes, many more patterns will emerge. Right now, you have to sort of get the collection of papers first, and there's a lot of them. Any of you that have looked at lit COVID can see that there's like way too many papers to try to get any of this ahead. So we got that funding. It's going. It's based on a prior research that we did that just focused on geographic location extraction. So that one we were able to get, again, for the records, the specific location or candidate location. So here I'm just illustrating how it was used to get for records that just say China, which is kind of big, to locate Wuhan as the location for that sequence. So believe it or not, the original sequence is not tagged with the right location or the precise location, at least not in GenBank. And so this is just that example. All right, so in conclusion, so real-world data is underutilized. Out of the 3 slides where I say that, I hope that it stuck. So real-world data is underutilized and could complement traditional studies to find the causes of health outcomes and diseases in populations. So yes, we have done, I didn't mention it, but we have done publications finding in social media people's age and gender and some other demographic characteristics like geographic location to certain degrees of success. So there's several papers published on that. So we can get that. We can get certain populations. We can get very specific geo-centered collections going, and we have done that. Findable, accessible, interoperable, and reusable data is essential. Methods also need to be findable, accessible, interoperable, and reusable. If we have those 2, we can really move from real-world data to real-world evidence. And in general, I believe natural language processing that utilizes machine learning and artificial intelligence to mine real-world data as a whole. And so you don't leave pieces accounted for in your studies. They're complementary. Social media is complementary for traditional studies. Electronic health records can bring, the unstructured portion of electronic health records will bring complementary views and data and knowledge into studies. So utilizing this will enable actionable, meaningful digital epidemiology. And with that, I conclude so that I can hopefully get some questions and discuss. Thank you.
Thank you very much. So great talk. We have some questions in the public and questions online. So let's start by the public.
Yes, hi. Thank you very much for the interesting talk. And I have to say, I also worked with textual data, and I feel with you. It has been a lot of pain, a lot of tears, so great job. My question is, when you use social media data, aren't you concerned about your data being biased, meaning that not everybody is using social media, so maybe you're missing some groups of people?
Yes, we are aware of that as well. And usually we have a whole little speech about that prepared, which is every single observational study will miss something. You name it, it has holes. It doesn't cover the entire population. It doesn't cover enough representative sample. So it doesn't mean that you stop using them. So basically, being aware of the biases and incorporating, to the extent possible, remedies for it is part of designing these studies that we do with social media. There's different things you can do. In general, for example, you could identify gender and age, and if you don't identify gender and age for a specific population so that you can rebalance or balance, you leave it out. The beauty of what we do with social media is so much data that we can basically take the luxury of saying, well, if it's not precise enough, I'm not using it. If I cannot tell the age of the user, basically that user is not included, and so on. You can do that. You can also rebalance, even if you say, well, if users are not present, well, then there's no solution for that. 5-year-olds are not tweeting, right? So we hope. But anyway, so there are aspects that you cannot address, but when you can address them, then you certainly should. And we do that in some of the studies. Thanks.
Thank you.
Hi. Thanks for a nice talk. And I have a question related to the first one. Speaking of social media, then possibly most of the English-based, but also including not English content. So first of all, if it's worth to also explore the not English content, and second, if we want to process not English content, how would you want to process
yes,
it?
most definitely we would like to process non-English content. Thankfully, I'm not the only one working on this. So we have people like Martin Kralinger, who's working on Spanish tweets, for example. And so what we do is we try to reuse what we can, but working with a different language obviously implies a whole different approach and pipeline to be developed so that you can process the tweets in other languages. We have, for example, the largest collection of COVID-related tweets. I started it January 20th of 2020. I started collecting every tweet that Twitter lets me get. So that's 350,000 of them per day, every day since then, and it's still running. So we have that, and we have run some analysis at some points along the way, and we got that about 70-75% of the tweets were in English. I got lucky here because COVID is called the same way in every language. So we did get many other languages in that collection. It's just the data is there. We can share it. It's very limited because of the limits. It's somewhat limited because of the limits that Twitter imposes on sharing data, but it's doable. I mean, you can, depending on the study, we could share some data in French and others, and other people have done it. Or data, we learned a painful way, is about the same that some others have collected on the same window. The same data was made available by Twitter. So we overlap. Or data overlaps with others. It's just that I have been running it for the longest time. But yes, different languages can be included in any kind of study.
Cool, thank you.
Okay.
So thanks a lot. Great presentation. I think my question is still about social media.
All right.
So something that I want to bring as an example, like, for example, about fake news and things like that. So we saw like a few years ago, Mr. Zuckerberg in front of the US Senate, I think struggling a little bit to explain essentially these fake news and all the rest and to control them. Or another example you brought is Twitter. So we know like Mr. Musk recently tried to buy Twitter, and then he complained that there might be bots, and even Twitter is struggling to establish what is the percentage of these bots. I was wondering what you think about that. Is that do you see that as a concern, and what do you think can be, following your approach, the strategies to try to distinguish what might be real news from fake news, or how to distinguish bots? Because we would expect also these kind of things to improve in time in terms of getting more difficult to recognize. So what's your point of view and how you would approach it?
We did develop a system to identify bots. It goes back to validation. So once we have a set of a specific set of data that we want to study, then yes, in a cohort, for example, we would like to know what percentage of that are bots or not. It is a very long answer if I were to give it a full answer. I do invite you to look up that paper. If you tweet, I can reply with the specific paper that I'm talking about. But basically, we took a system that used to be called Botometer. It is available. We use it as a basis for it, and then we added a layer specific to health. So we developed the model to identify bots. Making a long story short, the number of bots, once you have specific content, so for example, if we are looking for medication mentions, about half of them will be advertisements. And we've done that, we've looked at that. We can filter them out with the classifiers. The statins paper that I showed, half of the data was considered, if not necessarily bots, but it will be advertisements. Very likely bots, generated automatically. Not all bots are evil. There's bots, for example, that retweet about systematic reviews. I don't consider that a bad bot. It's a good bot. So there's good bots, bad bots. So you have to go through the data, identify, in this case, content that's unrelated or users that you're not interested in. I like twisting it on its head and say, I'm doing health-related studies, and I want what people say. So I'm interested in people. Everything else are institutional accounts, bad bots, good bots, whatever that is, I'm not interested. I want to identify humans. So the way I focus that problem is this a human or not, rather than is this a bot or not? Mm-hmm. And we did that. So we have those filters. Second part of that answer is the percentage is much lower than what will worry Elon Musk in the area of health. Because if we're looking at pregnancy announcements, right? I include the keywords, and then I do the filters, and then I do a classifier to try to find if this was a true pregnancy announcement. By that time, a bunch of the content that I'm not interested in is already filtered. So by the time I get to my data, and we have quantified that, it was about 5%. Only 5% of the users that ended up in our database are not really. There was one that was, believe it or not, repeating pregnancy announcements. I think it was meant to be so that like all users that announce their pregnancy will be available for commercial purposes or whatnot. I don't know. We have the user. We identified it. It had many pregnancy announcements in one timeline. So we sort of suspected as much. Like, cannot be. So there are telltale signs, basically. For health, it will be specialized, and you do need to validate your systems like that.
And maybe you should share this technology with Elon Musk so he can finally take a decision if to buy
No,
Twitter or not.
Then he'll be tweeting about what I do, and then
Thanks a lot.
shutting it down or something. Who knows?
We have 3 questions online. The first one is very much related to this one, so sorry, Guillermo Lopez Campos, I'm skipping that question. The second question is about what are your comments on text data on hard papers? It's made by Riwan, but I don't have any more.
Right. I couldn't get the question.
What are
Can you
your
try again?
comments on text data on hard papers?
Oh,
Printed, okay.
okay. Text mining for filter papers like publications?
Printed.
Printed papers. Like you
you
have to OCR it?
Yeah, exactly.
That was like way at the beginning before I even started in health. I did OCR. It is for older papers right now. Everything is available in textual. Older papers wouldn't be. And in that case, and sometimes the other time we faced that is a Mayo Clinic, actually. When they were transferring records, they transfer PDFs of records. So that will be another one. So there are PDF to text converters that actually literally is called PDF to text that we have used. And then there could be OCR technologies. I haven't checked them in a while, but it is possible to incorporate some of that. Again, validation will be key. You have to validate everything that you incorporate.
Okay, perfect, thank you. So let's go for the final 2 questions. So one over there.
Hello.
Oh, we have 3, yes.
So, good talk. I would like a few words out of you on a potential privacy concern that might arise when you concentrate ostensibly public information and correlate it into new ways, and the effects that may have for data use and reuse. So the background to this is about a decade ago, I spoke to a lady who did similar research, and she was mining Twitter for mentions of drug reactions, adverse drug reactions to certain drugs.
Been me, anyway.
Yes.
All me.
that will give you unpleasant experiences when taking drugs relating to antiretrovirals that will make you less
Then it wasn't.
capable of shedding HIV virus and being less contagious. So is it possible to detect what HIV positive people are planning to go out to have unprotected sex tonight, and what clubs would that be? And do we have a responsibility of stopping this activity? So no need to answer that particular question, but it shines a light on that these people may not realize that they are in fact speaking into a public arena with very private personal affairs, and they don't realize that this will be correlated, and maybe they will end up in a research database and being very identifiable. So this may have privacy concerns that may not always be addressed. So how do you see that?
All right, and that's why I put my disclaimer at the beginning that that's a whole other talk, and I have addressed it in other venues, but basically, two things. There is misuse of some social media data, particularly, for example, Facebook private groups. I've seen papers published that say, we created 10 fake accounts to go in and then scrape everything that was put in a private group. So things like that. So there's a line that you don't cross. In my particular line is anything that's available to any user of the platform and is publicly available then in that definition. Just because it's available to users of a private group doesn't mean it's publicly available, because the sense of the person joining that group is for privacy. And if any of you are in any of these private groups, you will see on occasion these cries for basically people being very annoyed at people sharing things outside of the group. And I'm talking about like small groups in a community and even large groups. So definitely not recommended. So there's ways of using ethically, ways of not. And unfortunately, both have existed. We had the Cambridge Analytica big scandal a few years back. So doing research in social media and using the data ethically is something that definitely will help everybody doing research going forward. That said, there are some surveys that indicate that when you ask people if they mind their information being used in aggregate, which is important, for health research and for other good outcomes or good studies or considered good of social benefit, they more often agreed that it was okay, right? Twitter, this is why I like Twitter a lot, and Reddit. Reddit is already considered anonymous, so posts are anonymous by nature, the way it is designed. And then Twitter, the rules of use of Twitter are very, very well understood by the people that use the platform. So Facebook fails to note things sometimes. So for example, some people don't know that when they put a hashtag in their Facebook post, it becomes public. So people get, search engines are available to mine Facebook data, and academics have access to it. But it is limited in some ways. But there's things like that, for example, it might, a few years back, it was true, I don't know if it's true right now, that that's the case, that if you put a hashtag, then it becomes public. So details like that are not well understood. So people might not understand that so well. I try to keep my studies and my research on Twitter and Reddit and WebMD. We do WebMD as well, because those are reviews publicly posted, and people know that they're publicly posting. So that's the thing, is like sometimes you have to just do a little bit of common sense of what people will like to or will expect to be known about themselves in a public arena. So I try to limit a lot the things that I put up on specific tweets, for example, and the papers that we publish. If it's something very, very delicate, we will switch the language. So we just basically alter the language so that it's not findable later on. Yes, for reproducibility and science, that tweet that we changed for an example will be in existence among other 1.5 million tweets or so. See what I mean? It's like people can find it anyway. People that will misuse it can find it anyway. If we restrict scientific use of it for the fear of this misuse, then all we're doing is removing ourselves from the stage and just letting the bad use reign. So basically, what we learn will help also counteract the effects of the other misuse. All our data is being used. All our tweets are being analyzed. That's how you get all the advertisements that you get when you're like switching to. So basically, it is already being done. That we can get some benefit out of this is, I think, one of the extra benefits of continuing work in this and not shying away from for fear of violating privacy. One step further is people are publishing on Twitter. So if they publish their opinion about a medication, I think more often than not, they want it to be viral. They don't want it to be secret. So in essence, by denying them the right to say what they want to say and giving credit back, we will be going against what people intended in many occasions. So it's food for thought. I wouldn't approach IRB with that little notion, but basically we just continue to protect when, in essence, the platform is made for public acknowledgement, I guess, of whatever it is that they are publishing. It's a mini publication. I would like my papers to be cited, right? People like their tweets to be cited and share and reshare and so on. So basically we're moving into this new era where whatever is out there, most of the time is done consciously, that it is public.
Lovely. Thank you.
All right.
Thank you. Very last question.
Yeah. I have something similar to ask. So a couple of days back, there was a post on Reddit where a parent was asking that their infant has 104, 105 degrees fever, and should they do something? And what I was thinking that, is it possible that once we have this real-world data analysis method to transform them into real-world action or real-time action, so that if we find something like this, then we can intervene and maybe give proper care to the infant and maybe also consider whether that person is capable enough to handle that infant. So do you think that's something which can be technically pragmatic and can be done in the future?
It could be. I'm trying to imagine, as you were talking, all the pieces that will need to put in place. But to give you a simpler example where it already worked is for hurricane rescue in Houston. The people were tweeting their address and that they needed to be rescued, and it was being used. So basically, it takes several things. It takes somebody listening and people actually using. And it is, as you said, one of the easiest ways to deploy a really complex health monitoring system with very little technology required or new technology required on part of the user or the patient or the person in need and authorities. It just needs to be put in place. It is possible. It is doable. The only thing, it needs to be done as a two-way method. Basically, just like anything, if you're just tweeting into the Twitter universe with no specific handle, with no specific hashtag, then the chances of that being heard are smaller than, say, you know that in Barcelona there is this monitoring system that is listening to things hashtag as whatever Barcelona virus, and then you know, and there's a public campaign where people know that if they tweet something with that hashtag, then they can get either immediate help or pre-recorded or pre-written messages with answering their questions, and there's a question answering system that works like that. So it has to be done in conjunction, I think. Otherwise, it becomes an epidemiological study like the ones we do. It's like, let's see how many people were tweeting about fever of 105 out in the world around, I don't know, March of 2020, and sore throat and stuff like that. So see what I mean? It has to be focused in order to be useful. And then it has to be well-designed in order to be obtainable. And then you have all these samples of data from across the United States and the world that have the thing that you are capturing. But it's just a sample. See what I mean? It's like it's disconnected from an immediate action because it's a sample that depends on what's made available by Twitter in this pipeline of data collection.
Okay, thank you.
Welcome.
Thank you very much for a great
You're welcome.
presentation.
Thank you.
Thank you.
My pleasure.